Welcome to my presentation on statistical properties of the Voynich manuscript text. I'm Schmeh, and this is the text we want to examine. It's 230 pages of text, 170,000 characters, and usually it's not a big deal to start an examination or a statistical examination of such a text in order to find out its meaning. So why don't we just try it? This is an example. This is a frequency analysis made by Kevin Knight a couple of years ago. The idea is pretty easy. Just count the letters. That's probably the easiest, or the first thing a cryptanalyst usually does when he examines such text. And in this case, Kevin Knight counted the letters and he found out that this one looking like an O is the most frequent one, and one looking like a C is the second most frequent one, and so on. And all this sounds pretty simple, but it isn't. Why? Well, first of all, which transcription shall we use? Most of you will know that there are different transcriptions of the Voynich manuscript, or at least 5 different ones. And for example, René said that a new one will be developed soon, so maybe the new one will even be better than the other ones. And finally, there are statistical examinations based on no transcription at all, so there's quite a lot of variety, and it should be clear, if we make a statistic, it depends of course on the transcription we choose. So this is problem number 1. Problem number 2 is, as you see here, the same letter can be transcribed as 1 character or as 2 or even as 3, depending on the transcription you use. And if you now want to count the letters, what are you going to do? Do you want to count a 3-character letter as 1 or as 3, or can we be sure if this is 1 letter at all, or should we assume that there are 3 letters or maybe even 2? It should be clear that questions like these influence statistical examinations. And problem number 3, what is about the different handwritings? Well, of course, the handwriting doesn't influence the statistics, but in this case, at least the handwritings A and B have different statistical properties. So I call this problem number 3. And finally, problem number 4, what do we use for comparison? Usually, it's quite easy. Usually, we take an encrypted text, we make a statistical examination, and then we can compare the result with other encryption statistics. But in this case, comparing it with encryption statistics is not enough. Why? Because there are other possibilities. Maybe it isn't an encryption at all. Maybe it is natural language, or maybe it is artificial language. Maybe it's a code based on letter omissions, or a phonetic code, or a transcription of something. Or maybe it's nothing at all, simply nonsense, and there's at least a lot we need for comparison, and this makes all these examinations a little more complicated, of course. Well, so if we look at these 4 problems, problem number 1, transcription, we have at least 5 choices. For the multi-character glyphs, at least 2 choices, and here again 2. So if we multiply all these choices, we easily get a total of 1,000 choices, and I'm only talking about the different variants of the same text. And it should be clear that this makes the whole thing quite complicated, because for every choice you get a different result if you make a statistic. There's no doubt about that. But now let's say that we have chosen 1 or maybe even a few of these different variants, and now we want to apply statistical methods. Well, no problem, but there are quite a few of them. I think 30 or more. And now the first conclusion of my talk is certainly, if there are many statistical examinations possible, and only very few of them have been actually made, so there's still a lot of room for research. And everybody who does research on statistical properties of the Voynich manuscript needs to make a few assumptions. So one assumption would be which transcription is best for the particular purpose. Okay, but anyway, there are quite a few statistical examinations that have been made, might be about 30 or something like that. And I'm going to show you what the most important ones of them show. Let's start with the most simple kind of statistic. It's the letter frequencies. That was examined, for example, by Kevin Knight a couple of years ago. He used the Courier transcription, as you see here. He didn't make a distinction between the two handwritings, and this is what he got. I already said, well, the letter resembling the O is the most frequent one. And now, of course, the statistics as such doesn't say much, because we need to compare it. For example, let's say we compare the Voynich manuscript letter frequencies with the frequency of German, English, Latin, and Italian, and we see, well, in this case, there's a certain similarity with English. But it's not as simple as that, because, as I said, there are many variants, many methods, and there's always something that fits. So I would call this simply a coincidence. I don't think that the Voynich manuscript is written in English, and at least I don't think it's written in modern English, because the numbers are from modern English. But it's the way you have to proceed. If you want to make a statistical examinations, you must make as many comparisons as possible and try to find what you get. It's close to natural language. So, and it's really within the range of natural language. Of course, it's only an approximation. There are different languages with different entropies, and Courier or the Voynich manuscript text is clearly within this range, with the hand A or the Courier A part having a higher entropy than the Courier B part. So again, we have one more argument for the natural language hypothesis. And now, this is the last examination I want to look at. It was made by Andreas Schinner, an Austrian physicist. You may have read his paper in Cryptologia a couple of years ago. I think it's the most recent publication in Cryptologia on this subject, and quite an interesting publication. He made 4 statistical examinations. The first one was a random walk. A random walk means you take a text, you convert it into a sequence of zeros and ones, for example, using the ASCII code or something similar. And then, for each one you make a step up, and for each zero you make a step down. And the more steps you make, the farther you may get away from the starting point, but it's also possible that you get back to the starting point. But in the average, or the average distance from the starting point gets bigger. It's more or less, or it's a logarithm curve. So if you take natural language or just a random source, you get such a logarithm curve. It means the mean distance between the starting point and where you actually are, it gets bigger the more letters you have. And now the question is, what is if you take the Voynich manuscript text, convert it to a sequence of zeros and ones, and make a random walk? What you get is, you get a bend at 72 letters. This is the result Andreas Schinner found. And according to him, this doesn't look like natural language at all, because it means that in the Voynich manuscript, there's a kind of memory effect. And it's an average value. That means no matter where you start in the Voynich manuscript, after 72 letters, you get a certain bend, which is based on averages. So it's not an effect at a certain point of the manuscript, but it goes all through the whole pages. And as I said, Andreas Schinner called this a memory effect. He made another analysis, the so-called autocorrelation analysis, and again he detected a memory effect which is not present in natural language, according to him. Then he made a similar token repetition distance distribution analysis. I'm not going to tell in detail what it is, but he detected regularity, a kind of regularity that, according to him, is not present in natural language. And then his final examination had the same result. So the result of Andreas Schinner's examination is that there's a lot of memory effect and a lot of regularity in the Voynich manuscript that is not present in natural language. And this doesn't look like natural language at all. And the question is, well, where do we get this memory effect from? And the regularity, where do we get it from? Schinner says, the Voynich text could be nonsensical text created with a stochastic method that sounds similar to the method of Gordon Ruck. So my conclusion, first of all, only a small part of all possible statistical examinations have been made so far, because there are many methods available that can be applied, because there are many text variants depending on the transcription and on other things, and there are many comparison possibilities. So there's still a lot of work to do. If we look at the examinations already available, we can say, fact 1, it looks like natural language. Fact 2, it doesn't look like natural language. And you may see that there's a certain contradiction between the two facts, and this is the problem we deal with. Fact 3 is, in the 15th century, certainly there was nobody who understood enough about language statistics to deliberately fake such a statistic. So there must be somebody who made a text that looks like a natural language in some respects, but without doing deliberately. He certainly didn't look at the language statistics. So my conclusion is, the Voynich manuscript text must be somewhere in between. It must have elements of natural language, and it must have unnatural or nonsense elements. And somewhere in between must be the truth. I know it's quite a distance between natural language and nonsense. A lot of it can be in between. It doesn't look like encryption. Encryption looks different. So I could imagine that something like a collage made out of words or word parts from natural language, and put this together in a way which is not really natural, maybe with a certain method, with a certain rule, whatever.